This is the Collections Framework Final Challenge setup. Using some combination of the classes in the Collections Framework, see if you can create the classes and methods shown on this slide. I've purposely excluded types and relationships here. This is called a conceptual model, where you start by drawing the needs of the system and identifying fields and methods. The information on this diagram should be enough to get you started. A product's information is defined by its manufacturer, so assume the information on product isn't mutable. A SKU is short for stock keeping unit and is a unique identifier for the product. The category should be one of a defined set of categories, such as produce or dairy for a grocery item, for example. The inventory item is the store's information specific to the product, things like price and quantities of each product in stock. The total quantity is the amount that's currently in stock, so it could be in any of your carts, on your aisles or in your warehouse. The quantity that's reserved is the product that's in the carts but not yet sold. The quantity reorder amount is the number to order of a given product. Usually when the low quantity total is hit, low quantity is the trigger or threshold to order more product. When the low quantity is reached, your system should order more product. The cart type has an ID and a collection of products that changes as a shopper adds or removes items from their cart. The cart will have a date and also a type to indicate if the type is physical or virtual. Each of the fields on the store class are collections. Which collection you choose is up to you. Inventory is a collection of inventory items. Carts is a collection of carts. The aisle inventory is the inventory that's displayed physically on store shelves. You can assume aisles can be keyed by the product category. Your store should have a method to abandon physical and virtual carts if the date associated with the cart is different than the current date. Think about the fields that would use collections and the types you have to choose from. You can also use collections to help you manage some of the functionality in the methods. Remember the three interfaces, list, set and map, and the classes that implement these interfaces. Do you need to allow duplicates in the collection? Do you need things to be sorted? Is insertion order good enough? Do you need a way to organize the data into a key value system to make some of the operations easier? What methods on the collections classes might be useful for some of this functionality? Would set math be useful? Or would navigational methods be simpler? Are there any methods on the collections class that would make sense to use here? This may sound like a lot, but take it one type at a time and one operation at a time. Collections are such an important Java topic, so take time here to challenge yourself as much as possible. Okay, so it's time for you to give this a try. After you've finished, or you get stuck on some part, come back and we'll walk through this together. I'm going to use the rest of this video to implement product, item, inventory and cart, which is mainly just setup and not specific to the collections framework except for the products field on cart. If you want to skip watching this part of the challenge, this code will be available in the resources section of the next video. I'll be using -days on local date, which simply subtracts whatever number of days you pass from the date you're using. I've created a new project for this challenge called Final Collections Challenge. I'm not going to have a main class on this one. Instead, I'll start with the store class and include a main method on that. Once I've got that, I'm going to set up some of my other types. First, I want an enum called category. I'll set up some constants in the order a store might be laid out, so maybe produce, dairy, cereal, meat, and beverage to start with. Next, I want a product, and I'm going to make this a record. Remember I said product should be immutable, which is why I want to use a record here. String SKU, string name, string MFGR for manufacturer. The last one will be type category, the enum I just created. I'll create an inventory item class next. I'll quickly add all the fields, all of them private. The first is going to have a product type and I'll call that product. Next is price, a double. I need 4 quantity fields. Quantity total is the first. The quantity reserved, total in carts, is next, followed by the quantity reorder. This is the quantity I'll order if a minimum threshold is reached. Quantity low is that threshold that has to be reached to order more product. I'll generate a constructor using the first three fields: product, price, quantity total, and quantity low. I'm going to add a statement in there to set quantity reorder to quantity total. This is the reorder amount. I'll generate getters for the product and price. Next, I want to create the methods, starting with reserve item. This method will get called as an item gets added to the shopping cart, so I want it to be public boolean and take an int quantity, which is the number of the product the shopper added to the cart. I want to see if the quantity being added is going to take my inventory below 0, so I'll make sure the quantity total, the inventory minus the quantity reserved, that's in other people's carts, is still greater than or equal to the quantity requested. If it is, I want to reserve that quantity, so I'll add quantity to the reserved amount and then return true. If there wasn't enough stock available for the shopper to buy, I'll return false. The second method is release item, again public and void, and it will take an integer for quantity again. Here I just want to decrement the quantity from the quantity reserved. This method gets called when a shopper removes an item from their cart. It would also get called during the automated process of abandoning carts, removing products from those carts, and unreserving their quantity. The next method is sell item, public, and it returns a boolean and takes a quantity again. This one will get called during the checkout cart process. If the quantity total, the quantity in stock, is greater than or equal to the quantity requested, I'll subtract the quantity from the quantity total. I also need to subtract that quantity from the quantity reserved amount. And finally, I want to check to see if the quantity total is equal to or gone below the low threshold. If it has, I'll call the method, place inventory order, which I still need to create. If enough quantity was in stock, I'll return true. Otherwise, I'll return false. Now I'll add the place inventory order method. I'll make this private since it only gets triggered by a condition that occurs in this class. I'll just print that an order was placed for now. Finally, I want a toString method. I'll replace the call to super.toString. I'm going to return a formatted string with product, price, quantity total, and quantity reserved. Okay, the next class is cart. I first want a nested enum that's going to tell me the type of a cart, so physical or virtual. These will be my constants. Next, my fields. First, I want a static field called last ID, and I'll set that to 1. You should be able to guess what I'm doing here by now. I'm going to use it to generate a unique cart ID for each cart. Next, I have 4 fields, the ID or cart identifier, the cart date, a local date. The cart type, so I'll use my enum type for that. Finally, I'm going to have some products. This will be a map keyed by a string that's going to be the product SKU, and the integer will be the quantity ordered. I'll insert a constructor with one parameter, the cart type. I want to include another argument, an int, that will adjust the actual date by a day or two. I'm doing this just to set up some test data, which will let me test the abandoned cart code. I'll add the assignments for the other fields here. I'll set ID to last ID, incrementing that field after. I'll set the cart date using the now method on local date, but subtracting any days passed to this constructor with a method on local date called -days. Again, this is going to let me set up tests with different dates. I'll make my map a hash map and instantiate it here. I want one more constructor, and that one will just be for the ID. I'll add 2 getters, one for ID and one for cart date. In addition to the getters, this class will have a method, public void, add item, and it takes an inventory item and a quantity. I'll next use the merge method with the SKU key I get from product on item. I'll pass it the quantity as the second argument and then the method reference integer : sum. This code, if the item's in the map, will add quantity to the current quantity, but if it's not in the map, it will insert a new entry using the quantity. After this, I want to call the reserve item method on the item, passing it the quantity. If I get false back from that, it means something went wrong during the reserve process. In that case, I'll just print a message. Okay, that's add item, and the next one is remove item, so it's public and void, and takes an inventory item as well as a quantity, just like the add item method did. This time I'll set up a local variable for the quantity, which I get from the products map on this cart. If this current quantity is less than or equal to the quantity passed, then I don't want to subtract more than I have, so I'll just set quantity to whatever the quantity is in the map. I'll remove the item from the map altogether, and I'll print that the product was removed. After the if statement, I want to call release item, which changes the reserve amount with the quantity from above. This code works if the quantity in the cart is less than or equal to the quantity passed. Next, I want to handle removing just some of the items, reducing the quantity in other words. If a shopper had 5 apples, he might want to put back 2 for some reason. That means I want an else statement. And I'll again do a merge. Instead of adding the values, I'll subtract the new val from old val and then print out how many of the product were removed. Okay, so that code should handle any quantity passed to it, even quantities that are greater than the quantity in the cart. It'll just remove everything at that point, removing the product from the map altogether. The next method is print sales slip, so I'll make this public and void again. I'm going to pass the store's inventory to this method because that's where I have the price of an item stored. I'll start with a local variable total that will keep track of the total price of all the cart items. I'll print a separator line and a thank you for your sale line. I'll set up a loop, iterating through the product's entry set view. I'll be adding code here in just a moment. After the loop, I'll print the total sales price and another separator line. Inside the loop, I want to get the item from the store's inventory. I can get the quantity from the products map using getValue. I'll get the itemized price, which is quantity times price. I'll add that to the running total of the sale and print out a formatted string, which has a SKU, the product name, the quantity of items, the price of each item, and the itemized price. Lastly, I want to implement the toString method on my cart class. I won't include type. That's good enough for the cart class. Now that I have the cart and inventory classes, as well as the product record and a couple of enums, I want to stop this video here. In the next video, I'm going to implement the store with its multiple different collections, so I'll see you in that next video.